Hello all, let us discuss on the maximum switching frequency which can be used um, across the MOSFET for controlling it, basically to turn on and turn off in switching applications. Now, the design engineers, based on the datasheet specifications that are provided, sometimes feel difficult to determine the maximum frequency at which it can be used, and there is a doubt across the engineers whether if example, if they are not using at maximum, also if they are using around 10% of that frequency, even they are not sure whether that frequency would work or not. So considering that scenarios, to just understand, the switching frequency basically depends on mainly the capacitances that are seen between the terminals of the MOSFET, whether it be gate to source or gate to drain or drain to source. These three are the capacitances which play a major role, because if you want it to turn on continuously or turn off, you need these capacitances to be charged or discharged. So those are the three major factors, and then definitely what is being provided to the gate of this MOSFET as a switching input, and then the kind of output that is connected over the drain. So all these basically play an important role in determining the switching frequency. Example, if you take FDN 327 data sheet, this is a graph which shows VDS versus capacitance, uh, and uh, mm, and this is provided at a frequency of 1 megahertz. So some of the engineers, if you look at it, might be confused and can take input that this frequency, this MOSFET can be used only at this specific frequency, but actually this is given as a characteristic at a specific frequency when there is no VGS input. So this cannot be taken as a actual frequency of operation of this MOSFET switching frequency. In reality, if you see, MOSFETs can operate in tens of megahertz of um, speeds. Moving further, so as we said that the switching frequency of this MOSFET depends on gate to source, gate to drain, and drain to source capacitance. The data sheet should help us understand what are the values of these capacitances. So to understand that, these capacitance values are not given straight away. They are given as variation of capacitance with the VDS, and that capacitances are more on the input output side, and then the on resistance. So if you see CISS, COSS, CRSS are the characteristics which are provided. So from these we have to determine the actual capacitances that we have talked about, which is like gate to drain. Gate to drain is directly given by CRSS, and then gate to source is determined by CSS minus CRSS, and drain to source is provided by COSS minus CRSS. So that means if you are operating this at a particular VDS, take the values of CSS, COSS and CRSS, and then determine the capacitances which need to be, which are actually the gate to drain, and then drain to source and gate to source capacitances. Now let us come to determining the actual frequency. Now that we understand on what it depends, so to put it in a simple way, if you see the switching characteristics of a MOSFET that are given in its data sheet, there will be charge characteristics, there will be capacitances, there will be rise time, fall time, and then turn on delay, turn off time. All these shall be provided at a given VDS, VGS and the drain current and also at a specific on resistance. So from these we can directly calculate the maximum switching frequency at which this can be used, because if you want to determine the switching frequency from the capacitances of the MOSFET which we talked earlier, it would be little difficult. So a straightforward consideration which we can do is the approximate switching frequency depends on delay time and mainly the off delay time. So it is you can say the switching frequency should always be less than 1 by turn on plus turn off time. So why we aren't considering rise time here is, example, this is a waveform which shows VDS versus VGS, the variation of VDS with respect to VGS. If you see here, and the definition of actual turn on time is nothing but the time for which the gate voltage goes to 10%, that means the charging of that gate capacitance, and till the time the VDS has gone up to 90% of its maximum value. So this completed time is called the turn on time, whereas rise time, if you see, is nothing but the variation of this VDS from 10% to 90% of this output, or the VDS voltage basically. So that means the rise time is actually a subset of turn on delay time is what we can say. So the turn on delay time is the actual time which is important, and then similarly the turn off time. So if you add both of them, you can know the actual switching time, and then 1 by it gives the actual frequency of operation of this MOSFET. So this is how we can determine the actual frequency of operation in a straightforward manner. So if next time if you are using a MOSFET and if you want to determine the switching frequency, the important thing is check the turn on time and turn off time. Now one important factor to remember here is, as we said, the switching frequency should always be less than 1 by T on plus T off. Additionally, if you can operate it at a 10% lesser than this, consider that as the maximum. Example, let us assume if the switching frequency is 10 megahertz. Okay, if you can operate it at only 9 megahertz, I think that's the exact consideration which we have given while operating this MOSFET. So from this calculation, negate 10% because we are here considering only till 90%. Which is, and again here there's one more 10% which is not considered. So we can negate approximately 10% from what we have calculated here and consider that as the maximum operation, which would give an approximate idea of frequency at which this can be used. So hope this shall help you in determining the maximum switching frequency. Please post your questions. Let us know if you have any doubts on this. Please like and subscribe our channel. Thank you.